Hello student. Now let us discuss about the inverse Laplace. We have seen what is the Laplace transform. Now see the first of all let us see the definition. So what is that definition? So if Laplace transform of f of t, this is equal to capital F of s, then what we have, inverse Laplace of this f of s is nothing but f of t. It's just like the derivative and integration. So what is that? Suppose if d dx of x is equal to 1, then from this what we have, integration of 1 is nothing but x. Okay, so the same thing is here. Whatever the Laplace of f of t, suppose it is f of s, then inverse Laplace of f of s is nothing but f of t. This is the definition. Okay, so let us see Laplace of inverse Laplace of some standard function. Inverse Laplace of some standard function, and from that you can easily understand how the process is actually. Some standard function, we have seen actually the Laplace of some standard function. So with that understanding, we are actually going to construct the results for inverse Laplace also. The very first result that we have seen, Laplace of 1 is equal to 1 upon s. Okay, and therefore from this, inverse Laplace of 1 upon s is nothing but 1. Isn't it? Okay, so these are inverses of each other. The second result that we have, Laplace of e raised to at. This is simply 1 upon s minus a. Am I right? This result we have seen in Laplace transform. So therefore inverse of 1 upon s minus a is nothing but e raised to at, like this. Suppose if we have e raised to minus at, Laplace of e raised to minus at, so this is equal to what? 1 upon s plus a, and therefore from this, what is inverse Laplace of 1 upon s plus a? This is nothing but e raised to minus at, isn't it? Okay, now fourth result that we have, Laplace of sin at. What is that Laplace of sin at? See, in some books you may find alpha instead of a, e raised to alpha t, sine of alpha t, or in some cases in exam you may have the result for sine alpha t or sine e raised to alpha t. So that is okay. A or alpha will be there. Okay, that doesn't change the meaning of the result and the concept. Okay, so only just alpha is there instead of a, that is fine. So sine at is nothing but a upon s square plus a square, and from this, what is inverse Laplace of this? 1 upon s square plus a square. Why a upon s square plus a square is not there? We have taken a common, sorry, a constant outside the inverse Laplace, and I have shifted that into this side. So this is sine at. Got it? Okay. So fifth result that we have, Laplace of cos at. What is Laplace transform of cos at? This is s upon s square plus a square. And from this, we can easily find out inverse Laplace of what is s upon s square plus a square. This is nothing but cos of at. So why we haven't taken this s outside? Because it is not a constant. This is a parameter actually, and our inverse Laplace is depend on that parameter s. Okay. Uh, Sixth result that we have is Laplace of, suppose sine hyperbolic 8 is there. So we have the result, only minus is there instead of plus in the sine 80. This is minus a square. And from this, what is inverse Laplace of this 1 upon s square minus a square? This is nothing but 1 upon a sine hyperbolic 80, like this. Okay. So seventh result, Laplace of cos hyperbolic at. So same here that we have. This is s upon s square minus a square. Instead of plus, there is a minus. And inverse Laplace of this 1 upon, sorry, s upon square minus a square. This is nothing but cos hyperbolic at. See, these all results, why I'm explaining this, because these results are important for online exam also. Okay, they may be in the final exam, and also we are using to solve the examples, okay, based on the inverse Laplace. That's why. So same here. So what is that? 8 result, it is the result of t raised to n. What is the Laplace of t raised to n? So it is nothing but simply gamma n plus 1 divided by s raised to n plus 1 for n greater than minus 1. So if n is rational, okay, in that case, basically we are using this. And from this, what is the inverse Laplace of 1 upon s raised to n plus 1? Why I'm not taking that gamma n plus 1 inside the inverse Laplace? Because it is again a constant term, as that of a we have taken outside in the sine and hyperbolic at. So same here, we have taken that gamma outside, and this is simply what t raised to n divided by gamma n plus 1. So this is gamma n plus 1. So if you want to design this formula in terms of 1 upon s raised to n, because every time you then you can just divide that power into n plus 1 form. So to avoid that, we just replacing n plus 1 by n. So what is here? So just power I'm reducing by 1. So this is t raised to n minus 1 is there, and divided by gamma n is there. I'm reducing that n by 1 unit. Okay, this is gamma n. This is it, and this is for n greater than minus 1 and s greater than 0, like this. Suppose we have this another approach for this. So Laplace of t raised to n, this is, it is n factorial upon s raised to n plus 1. So this is the result for n as an integer. So inverse Laplace of 1 upon s raised to n plus 1 is simply what? T raised to n divided by n factorial. Or if you want to design this result for s raised to n, suppose this is inverse Laplace of 1 upon s raised to n, then what is this? It is t raised to n minus 1 divided by n minus 1 factorial, like this. Okay, so suppose if we see the some examples. Okay, so here, to understand this, these are all the results. These are the basic results that we want to understand or to solve the inverse Laplace. Suppose find inverse Laplace of, what is inverse Laplace of 1 upon s plus 2? What is inverse Laplace of 1 upon s plus 2? So see, go for the result. What is s plus a? Inverse Laplace of s plus a is nothing but e raised to minus at. So what is this? This is simply e raised to minus 2t, like this. Suppose if I want inverse Laplace of 1 upon s raised to 4. Now 4 is an integer, use this result. So what is this? T raised to 4 minus 1 divided by 4 minus 1 factorial. What is t raised to 4 minus 1? This is t raised to 3 divided by 3 factorial. And this is nothing but t cube divided by 6, because 3 factorial is 6. So these type of small examples will be there in the online also. Okay. Now if I want the inverse Laplace of 1 upon s square plus 9. What is the inverse Laplace of s square plus 9? So this is simply inverse Laplace of 1 upon s square plus 3 square. 9 is nothing but 3 square. See here, we have the result. 1 upon s square plus 3 square is nothing but 1 upon x sine of 80. So this is nothing but what? 1 by 3 into sine of 3t. Got it? In this way, we can able to solve the examples. Okay.